Welcome to my channel Learn Mathematics with B.R. Panda. In this video, I am going to introduce a new function, Euler-phi function. Okay, and this function is related to applied mathematics of class 11th. Okay, so Euler-phi function. So Euler-phi function for any positive integer n greater than 1. Here this n is a positive integer as well as this n is greater than 1. Then this Euler-phi function is denoted by phi of n. Phi of n. Euler-phi function is denoted by phi of n and is defined as the number of positive integers less than n and co-prime to n. That means phi of n means we have to count all those positive integers which are co-prime to n and less than n. Let us take an example. Phi of 1 we can take because this n should be greater than 1. Phi of 2. So our aim is to find phi of 2. That means we have to count all those positive integers which are less than 2 and co-prime to 2. So how many positive integers are there which are less than 2? Only one, that is 1. And this 1 is co-prime to 2. That's why phi of 2 is 1. If we find phi of 3. So how many? These are the list of the integers which are less than 3. 1 and 2. And now we have to check out of these two how many are co-prime to 3? Both are co-prime to 3. So 1, 2. That means 2 is the phi of 3. Let us find phi of 4. So let us first make a list of all those positive integers which are less than 4. 1, 2 and 3. Let us check out of these 3 how many are co-prime to 4. 1 is co-prime to 4. 2 is not co-prime to 4. So let us strike out. 3 is co-prime to 4. So how many are co-prime to 4 as well as less than 4? 2. 1 and 2. So phi 4 is equal to 2. If we find phi of 5, so 1, 2, 3 and 4. Out of these 4 we have to find which of these are co-prime to 5. So all these are co-prime to 5. So phi of 5 is equal to 4. Let us find phi of 12. So to find phi of 12 we have to find the positive integers which are less than 12 as well as co-prime to 12. So let us find all those positive integers which are less than 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, so out of this 1 is co-prime to 12, 2 is not co-prime to 12, 3 is not co-prime to 12, 4 is not co-prime to 12, 5 is co-prime to 12, 6 not co-prime, 7, 8, 9 not co-prime, 10 not co-prime. Okay, 8 is also not co-prime. So how many are left? 1, 2, 3, 4. 1, 5, 7 and 11. So phi of 12 is equal to 4. Okay, let us learn some simple properties of this Euler-phi function. Properties. Property number 1. If P is a prime number, then phi of P is equal to P minus 1. If P is a prime number, then phi of P is equal to P minus 1. That means if we take one example here, so phi of, take any one prime number, phi of 3. So no need to count the numbers which are less than 3 and co-prime to 3. We can just write it as 3 minus 1 and which is equal to 2. Phi of 3 is equal to 2. So phi of 17 is a prime number. So directly we can write it as phi of 17 is equal to 16. So phi of 40, phi of 41, 40 is not a prime number. Phi of 41, you can write phi of 41 is 40. So come to property number 2. Property number 2. For any, if M and N are co-prime, M and N are co-prime, then phi of Mn is equal to phi of M multiplied by phi of N. If we take one example here, phi of 15, let us find phi of 15. Phi of 15 can be written as phi of 3 into 5. Here this 3 and 5 both are co-prime, 3 and 5 are co-prime to each other. That's why we can, by using this property, we can write it as phi of 3 multiplied by phi of 5, and since 3 is a prime number, phi of 3 is equal to 2, and since again 5 is a prime number, so phi of 5 is equal to, yes, 4, and which is equal to 8. Okay, this is all about Euler-phi function. Thank you.